Alright, let's go back and look at some of these earlier ones that we did to show you that we could have done these with synthetic division also. So here I was dividing a quadratic hotline. So what makes this divisor equal to 0? Negative 9. My coefficients are 1, 14, and 45. Alright, I bring down the 1 to start things off. Negative 9 times 1 is negative 9. Alright, and then add. So I add these together. 14 minus 9 is 5. And a negative times a positive is a negative. And 9 times 5 is 45. So I get a 0. Okay, this was x squared, x, and a constant. So this is going to be x, constant. Remainder is 0. So that's 1x, or just x plus 5 with no remainder. So there's my answer. And again, we see that's the same thing that we got here. Alright, this one that we did, x squared plus 4x plus 3 divided by x plus 3. Again, negative 3 makes this 0. And plugging in here, I get a 1, 4, 3. Bring the 1 down to start. Negative 3 times 1 is negative 3. Add, I get a 1, and then multiply, I get a negative 3. I get a 0 here. Okay, x squared, x, constant. So this is x, constant, remainder. So 1x, or just x plus 1, which is what we got right here. Okay, so synthetic division works for any of these as long as we're dividing by a line, meaning like x to the first power plus or minus some number. Alright, what about something like this, where we got this 3x minus 2. What about something like that? The answer is yes, you can, but it's made easiest, synthetic division is made easiest, or it has to be the case that the number in front of x when you do this process has to be 1. So what we have to kind of think of here is, in this problem, when I have the 6x cubed minus x squared minus 5x plus 4, and I'm dividing it by 3x minus 2. What I have to think of in my head is factoring a 3 out here. I have a 3 parentheses. If I factor a 3 out, it's division, right? So 3x divided by 3 is x. Negative 2 divided by 3, however, is negative 2/3. Alright. Now, what we've done is we've factored out that leading coefficient to make it just x plus or minus something here. But we're dividing by this now multiplication. These two things multiply together. And if you think about it, if you divide 12 by 6, that's the same thing as dividing 12 by 3 times 2. If I divide 12 by 6, obviously I get 2. But if I divide by the 3 first, I get 4. And then if I divide the 4 by 2, the second thing, I get 2. I get the same thing. So what I'm saying is I can do it in sequence. If I'm dividing something by two things that are being multiplied together, I can divide by one and then divide by the other. So what we do here when we have synthetic division, if we're going to try synthetic division on something like this, where the number in front of x is something other than 1, we have to divide the original dividend by this first. So x minus 2/3. 6x cubed divided by 3 is 2x cubed. Minus 1x squared divided by 3 is 1/3 x squared. 5x divided by 3 is negative 5/3 x. And then 4 divided by 3 is 4/3. So this is what we would actually end up setting up with synthetic division. In the box would go 2/3. And then out beside it, instead of 6, negative 1, 5, and 4, we have a 2, a negative 1/3, negative 5/3, and a 4/3. Right, and we bring down the 2. 2/3 times 2 is 4/3. And we subtract 1. So negative 1/3 plus 4/3 is 3/3, which is the same thing as 1. Alright, 2/3 times 1 is 2/3. 5/3, negative 5/3 plus 2/3 is negative 3/3, which is negative 1. And then finally 2/3 times negative 1 is 2/3. Alright, and then 4/3, that's a negative 2/3. 4/3 minus 2/3 is 2/3. So we get, this was x cubed, x squared, x, and a constant. So now this is x squared, x, the constant, and the remainder. So there's the 2, there's the positive 1, there's the negative 1. Now you may be thinking, well, where's the 2/3? Well, you got to remember this is what we set up by. This is our divisor. So it's 2/3 over x minus 2/3. Alright, and if we multiply the top and bottom by 3 to get rid of this fraction, 3's cancel here, we end up with a 2 on the top. And then distributing the 3 here, I get a 3x. And the 3's cancel here, minus 2. So that's where that remainder is coming from. So you can do synthetic division with linear factors, even if this leading coefficient is not a 1. You just have to do 2 divisions. You have to divide the dividend by the leading coefficient. And then you also have to then do the synthetic division with the altered divisor. So, I don't know, in my opinion, it's not really that much easier to do synthetic division in this case than it would be to do long division. I would have just done long division here, and I typically do long division if this divisor is a linear factor, but not just 1x plus or minus something.